Welcome. In this video, we'll explore the topic of normal distributions. Data can be distributed in different ways. There are many cases where the data tend to be around the center and symmetrically distributed. Such case is called a normal distribution. The distribution can be described by two values, the mean and the standard deviation. The mean determines where the peak of the curve is centered. The standard deviation stretches or squeezes the curve. Most people recognize its familiar bell-shaped curve. It is the most important probability distribution in statistics because many kinds of variables in natural and social sciences are normally or approximately normally distributed. Height, birth weight, blood pressure, or IQ scores are just a few examples of such variables. Please note that total area under the normal curve is 1, and it represents probability. The specific distribution of normal distributions is called a standard normal distribution. Let's see the difference between them. Of course, they both are bell-shaped. A non-standard normal distribution can take on any value as its mean and standard deviation, while standard normal distribution has always the mean of 0 and the standard deviation of 1. So we convert non-standard into a standard normal distribution. That conversion formula is called z-score. X is any observation value, mu and sigma are fixed values in each question. Again, the whole area is 1 and it represents probability. We use this z table for this video. There are negative and positive z-scores parts. This table tells us the total amount of area contained to the left side of any value of z-score. For this table, the first column corresponds to the first 2 digits of z-scores, and the top row corresponds to the second decimal place of z-scores. All the numbers of intersections give left areas to the z-scores. There are mainly 2 types of questions. One is calculating areas or probabilities given some observation value x, and the other type uses the reverse process. For the first type, convert each observation value x to a standard unit using z-score formula shown. Then, look up z-table to find the left area of z-score. If it is not desired area or probability, then we need to manipulate it to have the desired area. For the other type, we are given probability in percent usually. Read the corresponding z-score using table, and then find observation value x using the formula shown. These steps are in reverse of the first type. Let's try this example. First of all, identify the mean mu and standard deviation sigma values with symbols, since those are fixed values and used for all A, B, C, and D questions. If you review each question, you can see 4 numbers in the same unit, kilogram, with the mean or standard deviation in the first 3 questions. So those values are x values. And we find probabilities. On the other hand, you can see the percentage in the last question D. So this question is asking the original observation x value given probability. Question A. First of all, draw a normal curve and place mu of 2.36 at the center. Next, place a given x value 3.18. We mark it on the right side of the mean of 2.36, since it is larger than that. Think about the x line is a number line as weight loss values. We are at 3.18 now. Then read the question as less than, which means left side of 3.18. We shade all the way to the left tails from 3.18. That is our desired area. We know the mean 2.36 becomes 0 in the standard units. So let's convert this x value 3.18 into the number of standard deviations using the formula. Substitute the mean 2.36 in the top right and sigma value 1.04 into the denominator position of the formula. Then place x value of 3.18 on the top left to get z-score of 0.79. Please round z-scores to 2 decimal places. Let's look up the z-table using 0.79 to find the left cumulative area of the z-score. We find the left cumulative area up to the z-score 0.79. First, locate the first 2 digits of z-score as 0.7, and then locate the second decimal place of 9 from the top row. The intersection of those values is the left cumulative area to z-score 0.79, which is 0.7852. The z-score of 0.79 gives a left cumulative area of 0.7852. And it is our desired area. Therefore, the probability of the weight loss less than 3.18 kg is 0.7852. Question B. Keep the same mean and standard deviation values for this question as well. And draw a normal curve and place the mu 2.36 at the center. The x value is 1.23 for this question. So mark it on the left side of the mean since it is smaller than 2.36. Now we are at 1.23. We read from the question the keyword more than, which means right side of 1.23. We shade the area all the way to the right tail. This is our desired area. We know the mean 2.36 becomes 0 in standard units, but we don't know for 1.23. Let's convert 1.23 into standard units using the formula. Substitute the mean and the sigma values into the proper position of the formula. Then place x value of 1.23 on the top left to get negative 1.09. Please round the z-scores to 2 decimal places. Let's look up the z table using negative 1.09 to find the left cumulative area. We find the left cumulative area up to z-score negative 1.09. First, locate the first 2 digits of the z-score as negative 1.0, and then locate the second decimal place of 9 from the top row. The intersection of those values is the left cumulative area to z-score negative 1.09, which is 0.1379. The z-score negative 1.09 gives a left cumulative area of 0.1379. However, our desired area is the right side of negative 1.09. How do you find the right area? Here is a quick note for questions involving the more than some x value case. Our desired area is the right side of the given x value as shown in the pictures, regardless of the position of x value. However, our table gives us the left cumulative area. We know the whole area under the normal curve is 1, and we need the right side, not the left side. Therefore, we can just subtract the left area from 1 to get the right area. Now we know how to find the right area of the given value. Apply the formula 1 minus the left area of 0.1379 to get the probability 0.8621. Please draw a normal curve with mu 2.36 at the center. In this question, there are 2 x values. For the first x value 1.07, mark it on the left side of the mean 2.36 since it is smaller. For the second x value 1.83, we mark it on the left side of the mean since it is smaller as well. We read it at between, so we shade the between area of 2 x values. That is our desired area. We know the mean 2.36 becomes 0 in the standard units. Let's convert each x value into the number of standard deviations using the formula. Substitute the mean and the sigma values into the proper position of the formula. Place x1 value of 1.07 on the top left to get negative 1.24. We call it Z1 score. Please round the z-scores to 2 decimal places. Similarly, after substituting the mean and the sigma values into the proper positions, place x2 value of 1.83 on the top left to get negative 0.51. We call it Z2 score. Let's look up the Z table using Z score of negative 1.24 to find the left cumulative area. We find the left cumulative area 1 up to Z score negative 1.24. First, locate the first 2 digits of the Z score as negative 1.2, and then locate the second decimal place of 4 from the top row. The intersection of those values is the left cumulative area to Z score negative 1.24, which is 0.1075. That one score of negative 1.24 gives a left cumulative area 1 of 0.1075, shown in light purple color. Next, let's look up the Z table again using Z2 score of negative 0.51 to find the left cumulative area 2. Let's find the left cumulative area 2 up to that score negative 0.51. Again, begin by locating the first two digits of the Z score as negative 0.5, and then locate the second decimal place of 1 from the top row. The intersection of those values is the left cumulative area to the score negative 0.51, which is 0.3050. The Z2 score of negative 0.51 gives the left cumulative area of 0.3050, shown in gray-green color. That is not our desired area, as we need to find the between area of two values, which is in blue color. How do you find the between area? Once again, here's a quick note on approaching questions that involve the between area of two x values case. Each shaded region is the area between given two x values, as shown in the pictures, regardless of the position of x values. Again, we need to keep in mind that our Z table always gives us the left cumulative area. The purple area shows the left cumulative area 1 up to x1 value in each case. Similarly, green-gray color is the area 2 up to x2 value. As you can see, the gray-green area include the blue and purple area. If we take away the extra area in purple part from the gray-green area, then we are left with the blue color region, which is our desired area for all three cases. Therefore, we can use this formula to find the area between two values. Now that we know how to find the in-between area using the formula. Larger area minus smaller area. In this case, we have 0.3050 minus 0.1075 to get the probability 0.1975. Let's move to the last question, D. First, draw a normal curve with the mean 2.36 at the center. The question asks for top 10%. So we shade the right-tailed area with 0.10. We know the mean 2.36 becomes 0 in standard units, so we need to find the corresponding Z score to this area and eventually find the observation value x. However, as our table gives the left cumulative area, we need to convert the right area to the left cumulative area in order to look up the table. Since the total area under the curve is 1, we can get the left area by subtracting the right area from 1. Now let's look up at the positive side of Z table to find the corresponding Z score to the left area of 0.9. We need to locate the left cumulative area of 0.9000 or close to it from the inside of the table. We found two values close to 0.9. One is smaller and the other one is larger. Comparing the differences, one is 0.0003 smaller, and the other one is 0.0015 larger than 0.9. Therefore, we take 0.8997, which has a smaller difference, as the closest area to 0.9. To find the corresponding z-score, go straight to the left to read the first two digits, and go straight up to read the second decimal place of the z-score. So the z-score should be 1.28. If you are not sure about this procedure, please watch a separate video called The Normal Distribution Finding Z-Scores for more examples. We found 1.28 as a z-score using the closest left area of 0.8997. For the last step, find a cutoff value for top 10% using the formula as shown. Substitute 1.28 as z-score, multiply by the standard deviation 1.04, and add the mean 2.36 to get the cutoff value as 3.6912. It is a minimum value to be top 10% of the distribution. Rounded to one decimal place. Please include the unit of kilogram for your final answer. This concept, that is finding corresponding z-score given either left or right-tailed area, is very important for your other topics in statistics courses, such as hypothesis testing. I hope this video has helped you in understanding normal distribution. Questions, comments, suggestions are all welcome. Thank you for watching. See you again.